question 7 is a particle, an acceleration and forces question. We've got a wooden crate of 20 kilograms being pulled in a straight line across a rough horizontal floor. It's a rough surface. So it's travelling this way. So there's some sort of acceleration which we're being asked to find in part A. We've got the tension in the handle being raised to an angle of tan alpha. We're also told the coefficient of friction is 0.14. So what we need to do is we need to add all the information up here onto our diagram. We've got the 40 newtons already drawn. There's going to be a weight of 20 G newtons. There is going to be a normal reaction force to the floor. Because the box is on a rough surface, there's friction, and because the box is moving, friction must be at its maximum, and when friction is at its maximum, that's equal to the coefficient of friction times the normal reaction force. Now we were told that the coefficient of friction is 0.14, so we can write here 0.14R. So that's all the new forces we need to add to the diagram. The other thing I like to do is resolve the forces that are at an angle, so that when I come to looking at the resultants of the forces, I've just got everything right there in front of me. I can just do upwards equals downwards, because it's not moving up or down, and I can look at the left and right components to help me work out the acceleration. This right force here is going to be 40 times, when we resolve the force, cos of alpha, and this one's going to be 40 times the sine of alpha. Now the other thing that we're going to work out is what cos of alpha and sine of alpha are. Oops. And we can do that because we know tan alpha is 3/4, 3/4. Remember, tan alpha is the opposite over that adjacent. So in a little right angle triangle, that's 3/4 for the opposite and the adjacent. That allows us to work out the hypotenuse. That's going to be 5 for a 3, 4, 5 triangle. And then we can say that the cos of alpha is going to be the adjacent, which is 4 over the hypotenuse. And sine of alpha is going to be the opposite, which is 3 over the hypotenuse. So we could even change them here. We could say that this is going to be 40 times 3/5, and this is going to be 40 times cos times 4/5. But I'll wait and do that when we get down to the actual resolving of forces. So the first set of forces I'm going to resolve are the vertical forces. And as I said earlier, it's not moving up or down off the surface, it's just moving to the right. So upwards forces must equal downwards forces, which means we can say that R plus this 40 sine alpha will equal 20G. Now 40 sine alpha is 40 times 3/5. And 40 times 3/5, well 1/5 will be 8, so that's going to be 24. So R will be 20G minus 24. So 9.8 times 20, take away 24, is 172 newtons. So that's the value of R. That's useful because we can now work out this frictional force. Or we'll do that when we come to it. Because what we can do next is look at the left and right forces. Now because this isn't going to resolve, because it is accelerating, we know the resultant of the horizontal forces is going to equal MA. So the resultant of the horizontal forces is going to be, because it's moving to the right, this is going to be positive, so this will be our big value. So 40 cos alpha minus 0.14 r cos alpha minus 0.14 r is going to equal MA. 40 times 4/5, remember cos alpha is 4/5, is going to be 32. We know R is 172, and that's going to equal the mass, which was 20, times A. So A is going to be this divided by 20. So that's giving me an acceleration of 0.396 meters per second squared. That the force that they use is now coming down into the object rather than being pulled up like it was in part A. And he wants us to explain how that will affect the acceleration. Well, in fact, it gives us a clue. It tells us it will be less, and it wants us to explain why. Now, the reason why is because if you think about how we came to work out the acceleration in the first question, it was all linked with the friction, which was equal to mu r. Now, if we've got this force acting downwards like this, when we resolve it, we're going to resolve, instead of resolving in the first part, we resolved up and right. In the new question, we're going to end up resolving this 40 Newton force down and right. So that means that R is going to be bigger than it was before. Because before, R had to share the weight, if you like, with the component of the tension. This time, the thrust will increase the value of R. That is going to make F max bigger because they're proportional. So if the friction increases, and we did the cos alpha component from before minus the friction, if we're subtracting more friction, then the acceleration is going to be smaller. This value is going to be smaller because we're subtracting more. So if the friction increases, that will mean that the acceleration will be smaller.